Hello friends, welcome to Joy of Life. So today we are going to look at another medium level problem from LeetCode. The problem number is 63. The name of the problem is Unique Paths 2. It's the continuation to the earlier problem that we have done in this channel, Unique Paths, right? So let's check out the description. So it says a robot is located at the top left corner of a M into N grid, marked start in the diagram below. So there is no start, there is a robot. Actually, we can understand this is the top left corner and this is where our robot is. The robot can only move down or right. So once again, the move that is allowed to the robot is only down or right. He cannot go up or left. The robot is trying to reach the bottom right corner of the grid marked with mark finish in the diagram. So we can understand he wants to reach the start, though it's there is nothing called finish. But we can understand that this is the starting and this is the ending, just like the previous problem, right? Now consider if some obstacles are added to the grid, how many unique paths would be there? So unlike the last problem where the robot was free to move to any cell and find out the total number of paths, so what happened this time is there could be one or more obstacle in its path, and the robot is not supposed to step on the obstacle, right? So the robot, if he's here, he cannot come down to this cell, right? So this path is blocked for him. Even if he's here, he cannot come right into this box, right? So just a new constraint is added to the existing problem, and we need to come up with how many paths are there. So how many unique paths would be there is what we need. So we need to return an integer, just like the previous problem. Unlike last time where we have been given with a m into n, this time we have been given with an integer, two-dimensional integer array. So it says an obstacle and space is marked with 1 and 0 respectively in the grid. So yeah, this is the problem all about. We need to find out how many paths are there and we need to return that count back to the calling function, right? So I highly recommend you check out the earlier video. I will leave a card in this video as well, and also in the description below I will leave the link so that you can refer to that video, understand that problem, then try to come up with a solution before you check out my solution to this problem. So this is a very good starting point for a dynamic programming problem, right? So do give it a try and then continue watching the video. So let's move over to the board and let's check out the solution. So once again, I have taken an example wherein we have the robot, we have the end at the bottom right corner, and in between we have put some obstacles. Randomly, I have placed some obstacles. So once again, I would suggest you that if you haven't seen the earlier video, do check it out. It is connected to the same problem. I'm not going to go in very much details about what we did earlier, and we are going to focus more on the solution this time. Though the solution is not very different, but I still highly recommend that you go for that video as well, right? So once again, what we know from the earlier problem, the way that we can reach this row is there is only one way how we can reach this entire row over here, right? Since we don't allow a upward or left movement, so for the bottom also, this cells also, there is only way we can move, right? So for my desired cell, which is this one, for example, this one over here, how can I reach? I can either come from top or I can come from left, right? I can reach only by these two means. And if I can reach this cell over here with only one way, and I can reach this cell over here in only one way, so if I can add them up, I will get the number of ways I can reach this cell over here, right? So that is nothing but 2. And similarly for this cell over here, we know that it is 2 plus 1, 3. Because there are two ways to reach this cell, right? And there is one way to reach this cell. So I can either come like this, that is from the top, there is only one way I can come. And from left, I can come either this way or I can come either this way. So we will continue to do the same, but with the exception, that is over here where we have these obstacles, we will just consider them to be 0. So to come to this cell over here, we have only one means of doing it, right? We have to come from the top, right? So that's the only difference that we are going to deal the obstacle with, right? And we will get our intended results. So for this cell, I can only come down from the top. I cannot make it from the left. So there will be only 3 ways to reach over here. The same as this cell over here, right? We can come this way, we can come this way, or we can come this way. And all these 3 paths can lead to this cell, but there is no way from my left. Once again, for this guy also, it will be the same. So I cannot come down from the top. The only way I can come is from the left. And there are 3 ways to reach the left. But once again, this cell over here becomes eligible to come down from the top, right? And there is only one way. That is this way. I can reach this cell. And there are 3 ways I can reach this cell. So the result would be 4. So 4 plus 2 is again a 6. And as you can see, I can only come in the 6 ways over here. So yeah, this is the solution, and this is not much different from what we have seen on the earlier problem, unique path 1, right? So let's look at one of the edge cases where we So as we know that we put the base cases first, what if we have an obstacle in one of our base cases, or in the first row or the first column? How we are going to treat it? So what happens basically over here is this cells becomes unreachable. You cannot ever reach this cell. Since you're not allowed to go up, you cannot ever reach this cell. So nothing else in the problem changes, only that these cells become zero. So even if you have an obstacle in your first column also, it's going to be the same thing. So we do nothing, we solve as is. So over here, as we know that if it is an obstacle, then we consider it as zero. So 0 plus 0 is a 0, 0 plus 0 is a 0. So eventually these cells are also not reachable, because you can come from here, but you are not allowed to climb up, right? So over here, what happens? There is only one way you can come here, right? This is the only one way we can come here. So we need to take care of this edge cases also over here. So similarly, what if I remove this value over here, this one over here, and I go and take this obstacle and I put over here? So basically this becomes 2, right? But this actually opens up a lot of scenarios for us, because now we have a increased value, right? So what will happen is we have 5 ways of reaching here: 2 from the left and 2 from the right, right? So again 5 plus, so this becomes 5, and all the way it becomes 5 only. You can enter this 5 zone only from these 2 edges, since you're blocked over here, right? So we need to take care of this in our code as well. So let's head over to LeetCode and check out the solution for the same. So let's head over to the LeetCode and solve this problem quickly. So basically we have to create the 2-dimensional array that we have created last time. So we are going to create that, and we are going to call that paths, the same name, and we need the dimensions, right? And what we'll do is we'll get the dimensions in a variable, because we might need them later as well. Well, let's put I don't want to type because I am very good at spelling mistake, and I will end up doing some mistake or the other. So it's better to use copy pasting method, and for this what I'll do is 0.length, right? So this will give me the m and n, and what we are going to do is we are going to put m and n over here. Just like the last time, we know that for 0 0 cell where the robot is currently sitting, we will put that to 0, and at the end we are going to return m minus 1 and n minus 1, where we'll have the answer. This is nothing but the bottom right cell of our grid, right? And now first what we need to do is we have to establish our base cases. So just like last time, what we are going to do is we are going to iterate over this array that we have created, and we are going to set the edge cases, right? And we are going to set the base cases. So base cases is nothing but I0, we are going to set it to 1. So here is a catch, that we know that our base case could have a problem. In case we have seen an obstacle earlier, what will happen? The rest of the value should become 0, right? So what we are going to do is quickly we are going to see if in our obstacle grid that we have received over here. So in any of the cases, if we see a value of 0, then we have to change this thing. So let's do something. Let's get a variable called val equals to 1. So we are going to put val, but we are going to change val to 0 the moment we are met with the obstacle in the same row, right? And similarly the same thing we'll be doing over here for columns as well. So let's quickly put that down. So I'll be iterating over all the once again I am just going to put this same condition over here, but instead of I0, what we'll be doing is 0i, and we'll be changing the val, and once again over here also it will be 0i, because we are sticking to the column over here. So this will ensure that we have set our base cases as we have done earlier, right? And now we'll have this typical those two loop, but we'll start from 1 since 0 is taken care of. Then we are going to go paths.length, and I'm sure you're pretty much aware of what we are doing over here if you have seen the last problem. What if we find the obstacle grid over here? So we need to check if it is a obstacle grid. I'm not going to change its value, right? So if my obstacle grid is met over here with a value which is 1, that means there is an obstacle. Then I'm not going to do anything. I'm just going to continue over it. I'm not going to do any calculations, right? Otherwise what we are going to do is we are going to set our ij as we have been doing. So we'll be doing a paths I minus 1. So I'll go one step up, and you know why we are going one step up, right? And we'll be adding those values, paths, and the previous one, right? So let's refactor this. I did not realize that I took a m and n, so there is no need to do with paths and all. So what I'll do is quickly change them up. Oh, my bad. This will be 1 because our obstacle is marked by 1 and not 0. Let's run this code and check. Yep, we have our result. So let's submit and check for a wider range of test cases. Yeah, we are good. We again have a 0 milliseconds, which is faster than 100% of the submission. So once again, the idea was to give you the concept over here, how things are working, how dynamic problem is helping. And once again, I would like to reiterate, dynamic problem is not about remembering the pattern. Do understand why we need the table and what we are filling it up with, and where are we looking and why we are looking there, right? We have all the explanation that we want has been discussed in this problem, right? We know why this is 2 and why we are summing this up in order to come up with this value, right? So do let me know what you think about the solution. If you have any questions, doubts, do post it in the comment. I would be reverting them back as soon as possible within 24 hours or less. So yeah, that's all from this video, and see you guys soon. Stay safe and take care of yourself. Stay home and happy coding. Bye bye.